This is a great template to use to show kids why different decimals are equivalent to each other. Like they never know why 4/10 is equal to 40 hundredths is equal to 400 thousandths. We tell them to add zeros on the end, but that doesn't bring any understanding. When you see this on here, you'll just see, wow, I can get the kids to really understand what's going on. You can also model fractions that go to thousandths. You can do it either by expanded notation, or you can just do it right on the thousandth square. The best way to do this is to really use connecting cubes, and you take the 1,000 connecting cubes that come in a box, and you connect them all together as in length of 10, and you set them next to each other, and that would give you 10 different color squares. Each one, of course, has what? These strips that are hundreds, and then each individual unit cube or connecting cube would be 1,000th, because there's 1,000 little cubes. There are 100 of these strips, so those are hundredths, and then there are what? 10 different color squares, so they're tenths. And then you can transfer over this template, because here you have your unit. Here I took that unit and divided it into tenths. Here I took each tenth, divided it into tenths, and that's why these are hundredths. And then I took these and I made those into thousandths. So again, make sure that the kids have their own communicator, and make sure that the kids have their own template. The best way to do this one is to put the communicator on top of the template so they can move things around. So one thing you can do with kids, or you can model, is you can grab one of the rectangles and you can make that into 3 or 4/10 or whatever, but make that 4/10. You can use a different color, and you can show to the kids, I want you to highlight, or I want you to show me 4 100ths, and then you can say, I want you to take the next one and I want you to show me 4 1,000ths. So the basic thing is this very clearly shows kids, and that's hardly very difficult to see, but you get the idea. 4/10ths, 400ths, and 4,000ths are significantly different in size. One way that brings that just really out for kids to see. Another way you can do this is instead of using the shading, which shows up great, what you want the kids to do is you really want the kids to use a rectangle. And the reason you want them to do that is because you wouldn't have to shade it that way. If I take this and let's say I change it and I want to make that into a little bit different rectangle. If I just make it into a rectangle that they have to make, I'm going to clone it, or infinitely clone it. And what I can do here is I can then, instead of doing what I did with my shading, the kids really need to just outline it, and they can outline the next one and so forth. But it's a little bit faster for them. It's easier for them to see the answer if you did what I did before by grabbing the extension bar there and making it into a whole model. But anyway, why don't we take another problem, and this time I want you to show 3/10 on the tenths, 4 100ths on the hundredths, and I want you to show 7 1,000ths on the thousandths. So this gives kids just a little bit of practice with doing what we did. Again, if I highlight, I can highlight that in green, and I can show that as 3/10 right down that way. I can show the next one as 4 100ths, which we had a couple of minutes ago. So we want to just highlight the 4 100ths again. You want them to highlight that rather than shade it. And basically, the next one we want to talk about is 7 1,000ths. So we can do that in red, let's say. And you can get the kids, again, to see the approximate values of what's going on. Okay, so now, once we have our model, what we want kids to do is, we really know that 3/10 plus 4 100ths plus 7 1,000ths is 347 thousandths. So, if we want to reverse this, what we can do is take our models off of here so we can do another problem. And now, suppose I gave you a problem where I said it is model 600, 50 I don't know, 7 thousandths, and I want you to model those on the tenths, the hundredths, and the thousandths rectangle. So we know that there are 6 tenths, 5 100ths, and 7 thousandths. Again, this time we'll just highlight them like the kids would on their communicator. Take your bar, and the kids would highlight that as 6 tenths. Then they would take another one, and they would highlight that one as 5 hundredths. So I can move that over just a hair here, and I get 5 100ths, and I can do this as a model right there. 1 2 3 4 5. Move it over, and I have 5 100ths, and then I can show my 7 thousandths. A little rougher to see on the size that we have here. Kids do an easier job on the communicators, by the way. So that's roughly 657 thousandths. Now, what you could do is, after the kids get really good at this, instead of doing it on 3 separate papers or 3 separate models, what you can do is you can have them do it just on the thousandths, and this really will show if they really understand what's going on. 6 tenths. This time I will use my highlights so they can see it a little bit better. So 6 tenths is still 1 tenth, 2 tenths, 4 tenths, 6 tenths. It's still at 6 tenths. Now I could use the same color, or I could use a different color. I'm going to use the same color, and now I'm going to show 5 hundredths. So I could go 1 2 3 4 5 about halfway down, and they really need to realize that they can be approximations. They don't have to be exact, but you want to make them as close to the model as possible. But you get the idea of how to model these on your graph, on your template. So now you've got your 657 thousandths. Great questions to ask. Is that 657 thousandths? Is that greater than or less than a half? And how do you know that? Well, obviously it's greater than a half, because it shades more than half of that 1,000 square. Now on your template, when we look at your template, what we have here are 2 of those models, and the reason you want to do that is because you can say to them, I want you to compare 347 thousandths to 581 thousandths, or 58 hundredths. You know, that gets them. And you can model everything on the 1,000 square, and again, you would model this and model the other one on the bottom, and then you can compare the 2, and they could see that 58 hundredths is much larger than 347 thousandths. Again, that's why I gave you 2, and then you could write your inequality sign as well. So that's a couple of things that you can do with the modeling. You can also take this, and you can not only compare, but again, you can show them why 3 tenths and 4 tenths and 5 tenths are equivalent. This time I want you to just show me, numbers being the masters of disguise that they are, if I take let's say 4 100ths, 4 tenths, model it right there. No matter what I do to this, no matter where I move it, that is still, based on this model right here, that is still 4 tenths. So if I slide it over right there, actually slide the communicator over, the kids can see that 4 tenths is the same as 40 hundredths, and if they slide that over one more time, they can see that it is the same as 400 thousandths. Great way for them to see these equivalences, and when we tell them to add the zeros on the end, they'll know why these are equal, because they've practiced those with the template. You can also show addition on here. You can show other operations. Let me just quick show a addition problem on here, and basically I would do it in parts. So let's just take a look at this. I want to delete this. What I can do is I want to add 351 thousandths to 238 thousandths. Now there's a couple ways we can do this. I'm going to show this one in yellow and this one in green. So what we can do is break it into parts. You can do this as 3/10. That's 351,000 as 3/10. You can then show this one in 5 100ths. So you can take your model and show 5 100ths, 2, 3, 4, 5. And then you can show 1,000th. It's a little rough to show 1,000th, but we'll try it. Alright, now you've got your model here. Very good. Oh, there we go. So that's 1,000th. Hardly can see it. I'll do the other one in yellow. So that's 2 more tenths. And you can see that you have your 2 tenths. You can then show them 3 more thousandths, 3 more hundreds, and then move it over. You can show them 3 100ths, and then you can show them basically 8 more thousandths in yellow, and you can add that on. Now notice I didn't do anything with regrouping here, but the point is if I add 8 more thousandths, there we go. Well, let me move that up a little. So now what happens is your answer has got to be 5 1,000ths. 5 tenths. It's got to be 8 100ths, and it's got to be 9 thousandths. Or that can be read, of course, as 589 thousandths. You can do regrouping. Let's just, if you wanted to, you could just say, if this one was a, let's say, change this to a 7 instead of what you have there. It was 278 thousandths. What would the answer then be? Well, let's get this out of here. Well, let's see how you can model that. The only difference we'd have to do is this yellow one would have to take on the value of what? 7 100ths. So you had 5, and you have another 5, and then you 6 7. What's so cool about this now is when you go to see this, you really have 1 2 3 4 5 6 tenths, and then you have what? 2 100ths, and you still have 9 tenths. So your answer is going to be what? 629 thousandths. And of course, you guys who want to do it traditionally can also check it and see that it's 629 thousandths. What a way to model regrouping. Yeah, and this, of course, all leads to the fact that you can then take this and you can make this into a problem where the kids are actually doing this in terms of adding these together as partial sums. So again, if I rewrite the problem, and let's grab these right here, and I'm going to clone those to rewrite the problem, and let me just grab that, bring that over here. So now let me just add those together now, and I'm going to just make that into a line there. So I'm going to add my parts together. I'm going to add all my tenths, and I get 5 tenths. I'm going to add all my hundredths. I have 5 100ths, I have 7 100ths. I'm going to add that as a total of 12 100ths. And then the last one I'm going to add as what? 9 1,000ths. Now if you want to put the zeros in, that's fine, because we just practiced that a couple of minutes ago. And then of course the answer, I'm running out of space here, but the answer would be 6 tenths, 2 hundredths, and 9 thousandths, or of course 629 thousandths. Okay, we encourage you to do this in your class. Again, we didn't point these out at the beginning, but if you want to, you can obviously see some reasons to use this in your class. I have some activities that you can do. The best way to do this is to practice this and make up your own problems to get the kids actively engaged, and make sure again that you use think, pair, share kinds of activities where they're doing the problems on the communicator as you're either modeling it or validating answers that you've given them. Okay.